Hello everyone, welcome to session 4 of LTEC 651 Interactive Multimedia Production. In this week's video, we're going to cover 3 topics. First, I want to share a few ideas and observations. And then we'll discuss some of the features of H5P and its variants, and we'll end by taking a closer look at interactivity. So let's get started. I want to begin by talking about Design Project 3. I thought you all did an excellent job and there were some really fun and creative uses of hotspots. For example, I really liked Josh's side-by-side comparison of how to lift weights properly. I thought this was an excellent use of image with interactive hotspots. And this got me wondering if we could use an animated image with hotspots. So I tested adding an animation to the H5P image hotspot, and it turns out that you can, as shown here. And while we're on the topic, I want you to think a little bit about image hotspots from a cognitive perspective. And essentially, I'd like you to think about the question, why might interactive hotspots be effective from a cognitive perspective? Based on what we've covered so far this semester, you should be able to answer that question. I just thought I'd throw that question out there to kind of model the type of thinking that we should be doing as we explore different examples of interactive multimedia. And now I'd like to talk a little bit about the really excellent analysis that you folks did on the using computer ports example of multimedia. You're really demonstrating your ability to take the ideas and the theories that we're covering in the readings and apply them to this concrete example. Many of you pointed out that the start of using computer ports is actually kind of confusing. It's not clear what you're supposed to do. The visual element that draws the eye the most is the skip to challenge button. However, before you do that, what you're supposed to do is actually click on the ports. And as we know, many readers don't actually read text very closely, and so their default might be to actually skip the training and go right to the challenge. So that's an example about how the design of this multimedia is somewhat weak. Another common theme amongst your critical reflections was the fact that the language describing the functions of the ports was not very accessible. It contained a lot of jargon, a lot of unnecessary details, and didn't really focus on what that port actually does relative to all the other ports. And so many of you suggested that that language should be simplified down to its essence. Another really important point was made by Elle, who talked about how the pictures of the cables were only showing one perspective. But in reality, in the real world, what we want to see is multiple angles of that cable. Sometimes we have to actually turn the cable towards us so that we can see what the end looks like. And so here I'm showing a little bit of the Apple website and how they actually show you multiple views of a dongle or a cable to help you find the information you're looking for. Ideally, the using computer ports multimedia presentation would allow users to change those points of view. And actually, all of you made me chuckle a little bit to myself with how critical you were of the interactive role-playing activity at the end of using computer ports. Many of you highly criticized the time factor. It wasn't clear what you were supposed to do. It wasn't clear if you were supposed to click on the cables or drag them. And further still, some of you commented on how the facial expressions and the woman who's your colleague in this role-playing scenario was actually just extraneous load and not actually focusing on the task itself. But anyways, I wanted to share all of that because what I was seeing is strong evidence that you all are developing a critical eye about what is and isn't effective in terms of multimedia from a cognitive perspective. And this is exactly what we're trying to do. So keep it up. So now I wanted to spend a few minutes talking about H5P and perhaps answering the question, well, why H5P? So as you all know, I had all of you go out and investigate and put together a voice thread related to all of these other authoring tools and platforms. So why did we decide to use H5P? Well, there's a couple of reasons. The first reason is the fact that H5P is actually free and open source software. And of course, this is important in terms of transparency, privacy, and accessibility. And this brings me to the second point about H5P. There are actually two hosting options, h5p.com and h5p.org. So let's compare and contrast these a little bit. So h5p.com, which is what we used, is an example of software as a service, or SaaS. And h5p.com is hosted by Jubel, and their goal is to make H5P available to more people. And they're doing this by taking away the technical aspects of hosting your own instance of H5P. And of course, the money that they raise by selling this service actually goes back into further developing and supporting H5P development. Now, of course, many of you probably noticed or know about that there's also h5p.org. This is the actual open source version of H5P. Now, this version is self-hosted, and that means that anyone can take the code behind H5P and host it and run it on their own server. Of course, this requires some technical expertise, so not everyone is going to be able to do it, but some of the benefits of that are greater control over the styling of the components, and of course, a lot more privacy about who can access your content that you've created. Now, another benefit of h5p.org is that there are lots of examples and tutorials. And so it's really easy for anyone to take a look at what the different content types are and allow you to test what is it actually like to create one of these content types. You can do that right on their website for free. Now, importantly, these test cases aren't meant to actually be used by students. They're just there for authors to experiment with the platform. Finally, I want to talk a little bit about H5P standalone. And now this would be for someone who doesn't have access to a web server and actually wants a standalone version of their H5P content that they can just include in their website. Now, the standalone version allows you to create your own content on h5p.org, download that content, and then embed it in your own website without having it H5P actually hosted somewhere. Now, this is pretty technical. It's not something we could cover in detail, but I wanted you to know that this is an option. And if you're interested in learning how to do this, there's a front-end developer out there named Kristen Anthony, and she's put together a really great blog post and YouTube video demonstrating how to integrate H5P content in a standalone way into your own web pages. So be sure to check that out if that's something you're interested in. All right, so let's shift gears to talk a little bit about interactivity. Now, when it comes to multimedia, a good place to start thinking about interactivity is to think about what learners can actually interact with. And broadly speaking, there are 4 categories. There can be interactions between learners and other learners. There can be interactions between learners and instructors. Learners can also interact with content, and learners can actually interact with the system in which that content is embedded. Now, all of these areas of interaction are important in terms of research and design. However, as I've mentioned before, the cognitive perspective is largely focused on a single individual, a single learner interacting with a computer. So in this context, we're focused on learner content interactions and learner system interactions. Now, from here, we could think about, well, what types of activities can a user experience? Well, we can break those actions down into cognitive actions and behavioral interactions. And so let's take a look at a very simplistic 2x2 model of interactivity. Now, on the y-axis, we could have a continuum of low interactivity all the way up to high cognitive activity. And on the x-axis, we could focus on behavioral activity. So not what's happening in the mind, which would be cognitive, but what's happening with the body. What are you doing with your hands? What are you doing with your body? How are you moving? How are you behaving? And of course, that can go from low to high. So using those 2 axes, we can create 4 quadrants. In one quadrant, we could have high cognitive activity and high behavioral activity. A second possibility is the learner is cognitively very active, but behaviorally not so much. And you could imagine sitting in a well-implemented lecture might have you cognitively quite stimulated, even though behaviorally you're just sitting there and listening. You're not really moving around a lot. Now, the worst case scenario is shown here in the third quadrant, where you have very little cognitive activity and very little behavioral activity. That's probably the least effective way to actually have somebody learn something. One of the things we've discovered with multimedia is we don't necessarily want the fourth category, where a learner is cognitively not very active, but doing a lot of things behaviorally. They're moving around, they're clicking buttons, they're sliding sliders, but they have no idea what they're doing. In other words, they're doing a lot of stuff behaviorally, but cognitively, they're not very engaged. And so this is a very simplistic way of breaking down different kinds of interactivity or different combinations. Now, in the reading, we learned that interactivity is actually much more complicated. And importantly, the authors argued that interactivity in a multimedia context does not automatically create understanding. Interactivity itself actually requires two conditions. There has to be at least two participants or two things, two elements interacting with each other. The actions of those participants must include an element of reciprocity, which means that change occurs on both sides. The actions of one party trigger responses from the other, which in turn leads to changes in the first, so on and so forth. And of course, the authors came up with a very nice, important definition of interactivity in the context of computer-based multimedia learning. And they argued that interactivity is reciprocal activity between a learner and a multimedia learning system in which the action-reaction of the learner is dependent upon the action-reaction of the system and vice versa. I really like that definition, as well as their visual illustration using text and images, ironically, of all of the elements that really need to be thought about to have an integrated model of multimedia interactivity. Finally, I want to end by just sharing two studies with you. This first study is from 2004 from a journal called Learning and Instruction. And in this particular study, the authors were interested in to what extent do interactive dynamic visualizations facilitate the learning of a motor skill. In this case, the motor skill was learning to tie different nautical knots. So what they did is they created knot tying videos with two formats. There was a non-interactive format and an interactive format. The interactive version of the knot tying videos allowed the users to change the speed and the direction of the videos. Now, using those videos, they had 36 university students with no prior knowledge of how to tie knots had to learn to tie 4 different nautical knots. So what did they find out with this experiment? Well, they found out that dynamic visualizations actually accelerated the process of skill acquisition. The participants using the non-interactive videos took much more time to acquire the necessary skill for tying the knots. And they argued that the participants using the interactive features used them heavily. Viewers accelerated, decelerated, stopped, reversed, and repeated parts of the videos. And they hypothesized that this enabled the learners to distribute their attention and cognitive resources unevenly across the whole video. In other words, if we think about the limited capacity assumption that we can only process so much information at a time, being able to control the knot tying videos, the pacing and the direction really allowed these learners to focus in on the parts that were important for their understanding. In other words, those interactive features supported germane processing. Now, one last study, this is from 2012, and it's from the journal Medical Teacher, was interested in how interactivity in the form of direct manipulation impacted the clinical learning of how to give an abdominal exam. These were medical students. They had 3 versions of the multimedia module: a watch-only version, a click-only version, and a drag-and-drop version. And they tested these versions with second-year medical students, and they controlled for what the students knew, their spatial ability, and their prior experience with abdominal exams. And the students took a post-test after each module, and then they had to demonstrate the abdominal exam on a standardized patient, and they had to write down structured notes. So what did they find? Well, the researchers found that the type of content manipulation, no manipulation, clicking or dragging, influenced the clinical performance of novice medical students. Interestingly, students in the click and drag conditions were more likely to accurately identify the patient's diagnosis. The physical exam scores were significantly higher for students in the click group. And the authors argued that these findings suggest that the click condition, not the drag, had the optimal balance of intrinsic and extraneous load and of behavioral and cognitive engagement for this type of content. This is an excellent example of taking the theories about what should and shouldn't work in terms of learning through multimedia and actually testing it experimentally in a specific context. Okay, everyone, we're out of time for today. Thanks. I'll see you in Canvas.